And welcome back. In today's video we'll look at the Ampeak 2000 watt safe power inverter, which is a pure sine wave inverter. We'll look at it in depth because you might remember we also have the smaller brother or sister, whatever you want to call it, pure sine wave inverter from Ampeak, 1200 watts. I'm really curious how this one performs, and to be honest, I did take it already on a road trip and I used it and I tested it, and let me say it like that, I was happy with it. I was really happy with it. But before you make your own opinion about it, or I'll make my conclusion about it, we'll test it. We'll see how the conversion rate is from input versus output, and so that means efficiency. And we'll also test if we can draw the 2000 watt. I hope you stick around for the entire video. Let's start it. To get a better idea what's included in the box, obviously the inverter itself, as well as we have some kind of manual in here. We do have I believe it is a 6-gauge wire almost. It's a 20 square millimeter, and we also have a 14 millimeter wrench. And in this model specifically, you can see that's how you will mount the wire. I'm using a different wire because I have an endoser connected to it. And as you can imagine, with the 12 volt system, 2000 watt is quite a lot of amperage going through. So that means for this test we need a big battery. I'm using a 200 amp hour battery from Nearmark, and this battery should be capable of handling this Ampeak inverter with 2000 watt. So as I mentioned, I did already go ahead and install the wire, but nevertheless it is fairly easy. Those plastic covers come off and then you can just bolt it on. Like this, you can take it off. Like this, you can take it off, and then you just unplug it, and then you see that's why you need the 40 millimeter wrench. Ignore this cover, this boot cover, I had it on. I didn't want to put it away. But this protects just more the metal that is not exposed, so you're not accidentally touching it. And you are correct, behind there is the battery. But for now, we'll start with looking at the device itself. And that means taking a closer look what's on here. Conforms to UL standard 456. Conforms, not certified. Input is between 11 and 15 volts, so 12 volt fits perfectly in between. The output is AC between 105 volts to 125 and 60 hertz. As well as we have output DC 5 volt and 3.1 amp. Looking up front, with an on-off switch, we have 1, 2, 3 receptacles. But the third one looks a little different, a little more beefy. Let's look into that if we find some information about this. We do have the 12 volt cigarette lighter over here. And then we have the USB-C, which should have 3.1 amp. And then we also have this one, which is supposed to be a remote connector for on-off, I believe. I'll put an image in here when I find it, because I think they didn't change it in the meantime. It's still the same, which also would apply to the other inverter, which I didn't have, sadly, to test it, but that's how it is. When it's just on off, it's pretty simple. By the way, I did hear, and I hope I can make a video about that pretty soon, that when you connect this one with your Victron gear, you might be able to, when I say Victron gear, I mean my Raspberry Pi, for example, which is running Venus OS, and when you connect it with USB and this device to your Raspberry Pi, you might be able to control it through the Victron Venus application. Besides that, and besides just looking at the side of the inverter, we'll take a closer look in here, because that's something which was confusing last time, for me at least, for the 1200 version. So we do have in the display, which we'll see, an input voltage on top. Then we have an output current on the bottom and output voltage. So those two in combination should be 2000, I would believe. Then we have the output watts, which should be a maximum of 2000 watt, and a battery status, which is always just an indication. We also have the internal temperature, which should be inside of the inverter, as well as the output frequency, and it should be 60 hertz. We cannot change that. So we do have, and that's nice. That's what I was saying earlier, and I was wondering. So we have a 15 amp AC outlet, those two on the left, and the third one is a 20 amp AC outlet. Interesting. We should try that. Let me try to think if we have something to test this. We have the LCD display on top, obviously cigarette lighter port on the side, USB ports, and remote control port. And then we have the power switch. I told you it's a power switch, right? Let's see, I hope you can read it. So we do have a continuous input voltage, 12 volt, a range, input DC fuse. By the way, that's something which I have found, at least on those inverters so far. The fuses are usually built inside of the device. I might open it up later to take a closer look inside, because what happens is that they're not interchangeable. That's why they don't have a spare with it. They're usually inside, and it means they solder it on the board. I'm curious if this is the case with this one as well. So that's a reason why they might be able to sell it maybe a little cheaper. That's something just to be aware of. It's not a bad thing. It's just more complicated in case you need to fix it. So just saying. So we do have an output continuous, and we have an overload power from 2200 watt. We have an output surge power of 4000 watts. All right. I need to beef up my test system, I feel like. The output voltage waveform should be pure sine wave. We'll test that as well. Full load efficiency, higher or equals 90%. We'll test that one. Inverter overheat protection. Inverter temperature above 105 Celsius, 221 Fahrenheit. Most important, can I use the inverter with a 24 volt system? No. 12 volt system only. We don't have to go through the troubleshooting, but I think it's nice that they have everything on here. Safe protections. We do have a bad low voltage, battery low voltage protection, a DC cigarette lighter low voltage protection, over protection for an entire device, overload, over current, short circuit, overheat, overcool when it's below internal communication error port 1. Okay, I don't have to go through everything in detail, but you get the point. They have a couple of information in here. Also interesting for everyone else, I guess. Here's this page, 18-month limited warranty policy. Okay, do you want to be with me when I turn it on the first time? Let's do it. That's it. So we can see the entire display. So here we can see the display. As much as I remember with the 1200 version, it's always lit up like this. It's not super bright, but it is bright enough. So you can see it. It's when it's a little darker, it has like a little blue light to it, which, you know, just get used to it. We have the display. We talked about it already. We see the input. It's at 13.1 volts. I thought the battery is pretty full. I want to double check. Oh, can you see that? Oh, that works. I want to see the voltage, which says here in this device 13.1, how accurate that is. In comparison with the multimeter. We have 13.3 right now. Let's turn it off, and then we can turn it back on. There we go. There's always the fan kicking in. But it's still saying 13.1, that's fine. Let's stick with it. As I mentioned, always take this display in terms of battery with a grain of salt. And output, it says it's at 120 volts, so hopefully on 60 Hz. We hope that this will be a solid and stable connection. Alrighty, so we can see right now I have plugged it into the middle AC outlet. It looks like a pretty solid pure sine wave. And let me just plug something in the other port. Right now you can see the load should increase. What are we getting? 300 watt? Yeah, 300, should be around 400. Yeah, there we go. 400, and it looks pretty solid. That is nice to see. You remember I used this same test device here to see and to define if it's a pure sine wave inverter or not with this inverter up there, which was not, or at least it was having a lot of interference in here. So this one seems to be pretty solid, at least with around 500 watts. There we go. Nice. That's good to see. We're pulling 500 watt. I'm charging with this outlet over here. I'm charging another power bank or power station. I'll show you the display later. But what I want to do now, I want to see how much we're pulling actually from the battery right now. So that means we'll use this little friend. And we are pulling around 41 amps. 41 amps with 12 volt. So this one is running back and forth a little bit. I'm curious, that's what I want to see really quick. Because what we also see in here is usually we see the hertz and we also see the volts. And I see on the display, which you don't see right now, I see here it's 115, and it's saying 116 on the display. Now here it's jumping from 130 to 115. It's still holding it, but it's jumping up and down a little bit. So, but it looks good. Same happens on the display, so it seems like it's pretty true what it's telling on the display, and that's something which is nice to see, to confirm that. So I'm not telling you what device we're having here, but you see in the upper corner, this one is the input, which means around 435 is what we're receiving at this device, and we are pulling 501. Yeah, 435, I would stick with that. That's fine, and 503. That's the efficiency we do have here. So that means at least we're having efficiency about 86%. It should be always above 90, as you remember. So that is not the case. But it is pretty good, I think. Well, I've seen already other inverters which didn't have that at all. So let me hook up a little bit more power and see how far we can go. I have no idea how far we will be able to go. I'm putting in the heat gun right now into the 20 amp receptacle. And I'll sort it in a low setting. And now you can see we're pulling 1200. And with this battery, we have a maximum of 200 amp for 3 seconds. So it means 166 amp, which is equals to the 2000 watt. We should be able to pull somehow. So let me see if we increase it here, getting up to 1900. So the maximum of the battery is 2400 actually. Okay, we are close, 1900. Let's measure what we're actually pulling out of the battery, just to compare it again with the multimeter and get some clarification here. 193, not 194. Yeah, 194. We're pretty close to the maximum. Okay, there we go. 13, 14, let's go higher. 2000. Wow, we are above 2000 right now. That's pretty good, nice. Let me see if I can increase it a tiny little bit. I'm not getting the last 200 out, okay. Nice, it's still running. I mean, the fan is running, internal temperature, 128 and increasing. It's all plastic here, by the way, the orange. I thought it's aluminum last time, but it is just plastic. So no cooling surface, just aluminum on the bottom. Fans, you can tell here on this side, they're working pretty nice. All right. It's above 2000. This one is rated for 2000 watts. Guys, this is already impressive. They claim 2200. Okay, I didn't do that. But we should also be able to have a surge. And let's see when we kick both in all the way, how far and how long we can get this surge running. Okay. There we go. 17, 19, 2000. Okay. Just always like to touch the wires here because they're getting a little hand warm. All right, let's do the surge. 1, 2, 3. The heat gun didn't even start. It was just neat, 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 and then it stopped immediately, so it didn't get to all power at all. All right, cool. Good test, actually, good test. You see it is bigger. Those are the dimensions. And also the weight, just that you have an idea what we're dealing with here, or what you're dealing with. One comment I want to make, the wires that deliver with it, pretty good. 200 amp. So, and here it comes the very interesting part. I received 2 of those inverters. This inverter came with the 200 amp rating on those, let me see it here. Here the writing, 200 amp. And the other set came with those ones. Can you read 150 amps? When you use the full 2000 watt, you want to have at least 160 amp. Oh, sorry, 170 amp ideally. And ideally you want to have a little buffer on top as well, because that is otherwise very close. Because the wire is getting hot, and depending on your use case, as always, use bigger wires rather than smaller ones. You don't want to have anything overheating. I want to know what a standby power consumption is. And it is pulling 1.6 amps. And 1.6 times 12 is 19.2 watt. That's just the idle consumption, which means for the display, for it is just on and doing nothing. So that's why a remote might be good, depending especially when you want to install this device in your, let me say, in your camper van or somewhere else. You would like to turn it off from time to time, because this one, when it's just running and idling, it can also empty and drain your battery at one point. So keep that in mind. Almost forgot to test the cigarette lighter over here. It says 0 watt. And I do have connected my little Vecchi's car refrigerator. And it is, yeah, compressor is running. Interesting enough, it's probably so low, it should be about 30 watts. It says it's at 0 watt. Quite interesting. Let me turn this off. I'm really curious about that part. Turn it back on. Fans kick up. Right now it's still at 0. The thing is, the compressor takes always a couple seconds to turn on before something happens. Yeah, the compressor is running. It's connected. It says 0 watt. And still, it is running. I hear it. Still 0 watt. Let me measure how much we're pulling. It is pulling all 3.8 amp for the fridge. And, you know, a little change as well for the 1.6 amp for the inverter itself. So quite interesting to see that the display doesn't recognize the cigarette lighter. Yeah, the output stands at 120 volt, 0 amp, 60 hertz. Let's test the phone really quick. Okay, here we have the phone. Then here we see the percentage. I think we're at 54. I think we're 54. Let me plug it in. I will find it. It's hard with one hand. Oh, there we go. And it says charging slowly. Alright, I downloaded this app, and I hope I can show you at the same time what happens. So it's plugged it in. 4.68 was the base, and now it increases to 5.26. And it says here on the phone it's at 1.5 or 1400 something milliamp, and it says it's fast. So just to give you an idea what it is capable of in terms of charging a phone. But you didn't see that information here on the screen at all. Oh, and one last thing, it goes back to 0 watts. So it doesn't show its own consumption, but it also shows the output at 0 watts right now. So it's great. Last time I saw, I think it was the 1200 version, it never went back to 0. Sometimes didn't go back to 0, which was weird. But this one does. So good to see. All right, after all this testing, what do you think? Well, actually, what do I think? I'll answer that question first. But you can leave all the comments in the comment section below and all your thoughts if you want to share that. For me, it was very impressive when I took the inverter already out into the nature. I had 2 100 amp hour Power Queen mini batteries connected to it. With those, I was able to power this inverter. I used it on low, so it means it had around 1200 watt consumption. I didn't put it in full blast. It was just for a small tiny space, but it was heating up spaces which had around 25 Fahrenheit. So just to give you a perspective, the outside temperature was definitely a little colder when it started, and then it warmed up over time, and that worked pretty well. I didn't have any issue. That was very nice and very refreshing to see that this inverter was just holding up to that very easy. Right now I'm still charging with 500 watt, and I don't hear, or there's no fan kicking in at all right now. That's also pretty nice. So when you have some loads around 500 watts continuously pulling from a battery, great. Not an issue at all. When you have sometimes more, like maybe a coffee machine, maybe an AC, it should be pretty good to handle the surge power of up to 4000 watt. I don't have an AC to start it, so I wasn't able to test that part. This device is rated for 2000 watt and it goes above already. Amazing. That's all you want to see. You don't want to see something below. You want to see above or equals. And that's pretty nice. Yeah, regarding the wire, that's always the question. Are this wire thick enough and big enough? So I was doing a little research, and, you know, depends on where you go and what you see. So it looks like it's in between a 6 and a 4 gauge wire. When I look at my other chart, when I pull around 160 amps, 170, it should be between 1 gauge and 2 odd gauge. So where do you go? It's really up to you in terms of I'm using the full 2200 or 2000 watt, or I want to use less. And that's then defined the wire appropriately. That's a huge disclaimer you should be aware of and you really have to deal with. There's tons of stuff you can read out there, what size wire you need. I tested it here with a 4-gauge wire, and it got already pretty warm in my hand. Still, I was able to touch it, but it was getting really hot, especially pulling the massive load. So you want to go definitely bigger. Don't fool around with that, and buy quality wires for that. I think those are my thoughts. I'm more impressed than I thought at the beginning. So let me know what you think about it. Thanks for watching. Cheers!